In this chapter of Measuring and Vector Tools, we will learn how to create lines and polygons. We'll understand 2D and 3D measurements, comprehend vertex snapping techniques, and become familiar with exporting vectors for the use in third-party software. Also remember how we come about the name of photogrammetry, the science of making measurements from photographs. When broken it down, photo refers to light, gram refers to drawing, and metry refers to measuring. While the deliverables produced from Pix4D Mapper can be loaded into third-party software, there are a few tools available that enable measuring. In this chapter, we'll explore how to derive linear and area measurements from the DPC. The measurements may also be used as vector data, which may be imported into a third-party software. As with the previous chapters, we'll be working with a pre-processed project. The project data and the images are located in the L6 data zip file, of which you'll see on my desktop. And you'll get this by either means of a handoff from the professor or your direct download. But what you want to do is copy the L6 data zip file to your hard drive and then open it up as we've done before. And then drag the folder over to your last name underscore PIX4D file. And once this is complete, then take a look at the file, which is the L6 data file, and notice that all the images are in there, and that there is under the O2 project, there is a folder name measuring Pix4D file. So since we have been given this pre-processed project, we're just going to open it rather than creating a new project. So just double click on the measuring, which is a Pix4D file. Once that occurs, Pix4D will come up and ensure that if you get prompted, that the relative paths to the images, of which is asking for me now, and we're going to go into that and give it to the O1 image file. And we're going to select that folder, and then that will they'll load it, and up comes the image. At this point, click on the Ray Cloud tab. At that point, once you click the Ray Cloud button, make sure that the camera is clicked off. Make sure the point cloud is definitely clicked on, and all the underlying areas is also checked. Now it's possible to create lines that serves as a linear measurements in Pix4D Mapper. Each measurement will be saved as a vector, and vectors are known as objects. Now I want you to locate the white and red car in the center of the project, and notice this project is really a mock car collision. Now let's zoom into that area. Now I want you to notice a couple things. Notice that just to the left of the white car is a yellow tape that's on the ground or on the asphalt. Before image collection, a tape measure was actually extended out 20 feet. And we will measure this to confirm the length of the DPC. Now I want you to move in close enough to the tape on the ground so you can have a good representation of that. And then click the new polygon line. That's right underneath where it says create. You'll see this little polygon line. So click that. Then move the mouse to the bottom end of the tape right there. You can move in a little bit closer if you want. And then left click that. And then locate, so you want to drag your mouse all the way up to the other end and right click that one. Now you'll see the pegs, and this will create a green polyline that spans the length of the tape. Now if you made a mistake, you have to delete the polygon line, the polyline. So go down to the objects, right click on that, say remove. But if you notice, that the pegs are still there. Now these are really manual tie points between the two. So if you go up to the tie points and go on down, you'll see a manual tie point 2 and 3, of which has not been, it has 0 measurements. So right click that, remove that one, remove the other one, and it basically clears it all up to ground start 0. So again, we want to get a confirmation of this 20 foot. So we go up to and select the polygon line, the polyline. You notice it's sitting here waiting for you. So we'll go down to the bottom and we'll left click, and then we'll go all the way up to where the tape is, and we'll do a right click, and there you go. Now take a look at the properties section window, and under selection, the measurement for the polyline is displayed, and it was mentioned that the absolute length of the tape was 20 feet, if you remember. So if you look up into the selection window underneath the measurements, it's noticed that it says 6.12 in this particular example. Yours might be a little less, might be a little bit more. But what does this really mean? Well, since the units for the project is in metric, we now need to convert meters to feet to really understand what this measurement is. And there are 3.28 feet per 1 meter. So let's convert the meters to feet, and we see that it's 20.07 in this example. Now this means that the measurements of the tape in the DPC is accurate by 0.07 feet. Operator interpretation must be taken into account, of course, into the consideration when making these types of measurements. Now it is possible to create polygons that serve as area measurements in Pix4D Mapper. Each measurement will be saved again as a vector. So we're gonna find the new surface button, which is up here. It's a square in the Create toolbox, and click the new surface button. And similar to the new polyline techniques, the task is to identify an area and digitize the object around it. So let's move our mouse to the top left corner of the white awning. So let's first find that. It's over here. Zoom down into it a bit. And you can remember the tools that you can use. So we can get a good shot at that. So top left corner, we'll do a left click of the mouse. Go down to the bottom one, click there, and over to the other corner, click left click there. And then when you're finished, we'll just do a right click. If you notice that 4 pegs in each corner has been established. Now it's important to understand the difference between a 3D and a 2D measurement, as reported in Pix4D. A 2D measurement assumes all points lie along the same vertical plane. The reference from which the points are being snapped to the DPC is basically it's flat. If a line extends 50 feet up a vertical wall, the vertical wall portion will not even be accounted for because it's all based on a 2D plane. Now 3D measurement does not make this assumption. In the latter example, the vertical portion of the line will be accounted for when reporting the measurements. Now rule of thumb is that 3D measurements are generally longer and larger than 2D measurements. In this chapter, the technique of digitizing vertices has been performed by snapping to the appropriate points found in the DPC. The precise adjustments or movements of vertices, however, is performed directly in the original images. This adjustment allows for a higher level of precision since the discrete features are easier to interpret this way. So let's locate Polyline in the Layers window and click on that. The layer will become highlighted, of course. The properties for the layer will be displayed in the section area of the Properties window. Finally, the images that align with Polyline will also be displayed in the Images section of the Properties window. Now let's hover our mouse over the image called DGI 0496. And if you notice that when we highlight it, it turns a little orange border. And when it does, the space bar, Notice the green lines and X's in the photo. See down here below. They really do appear to be the same line as you originally created. Now roll your mouse over the green X to the right, and if you notice it changes from a standard arrow to a movement window. So we click and hold the left click of your mouse, and then while holding, a yellow extension is displayed as well as the crosshair. And notice that you can position a yellow crosshair would determine a new location. So in this particular case, I want to know what the length of the car is. So I'm going to be putting that approximately about there. And then repeat the exercise to the left one. Click and hold. And we'll put that about right there. The vertices adjustment must occur with at least 2 images. So now what we're going to do is hit the space bar, and then we're going to locate 0905, which is right to it. We're going to hit the space bar again, and we're going to take and basically do the same thing, approximately right there. And the other one is approximately right about there. So to do this, then hit the space bar, come back, do this, repeat this process for the next 5 images for a total of 7. Once you have finished this, click the Apply button underneath the selections. And you can take a look at our measurements did change. By adjusting the position of the vertices, the length of the line changes. So to practice, perform steps that we've just gone over, this section to layers surface 1 to adjust the vertice of the polygon. Please do that for practice, and then we can resume. When exporting vectors, both lines and polygons created by Pix4D Mapper may be exported as vector data for use in third-party software. Now, regardless of the amount of lines and polygons created, each one may be exported individually, or you can export them all together. So let's locate polyline 1, and we're going to right-click that and select the option that says Export. An export window, of course, opens, and it would be appropriate to save the files in the O2 project folder of L1. There are 4 file formats available to you, SHP, and if we pull that down, you can see all 4 of them, .dxf, DGN, and KML. So you can select anything that you want, but let's go ahead and name this Polyline 1. And then we'll click it's an O2 project, so let's click Save. If you have not done so, create a random second polygon somewhere on the map. Doesn't make any difference where. Ensure you have layers named Surface 1 and Surface 2, like we have on this example. Next, we will export both or all of the polygons into one single file. So we're going to locate on above that where it says Surfaces. And then we're going to right-click that, and it says Export All Surfaces. And then in the export window, select the SHP, which is the ERC shapefiles. And we're going to name this all underscore polygons. And then we're going to select the save file. Now let's go ahead and open the navigation window, which we have over here. And we're going to locate this file, which is under your name, Pix4D file, L6 data, then go to the O2 project. And you'll see there you can find all of the shape files that were actually saved for this. And you open a third-party GIS software, and you can import your shape files and confirm that they have correct geometric and coordinates. All vectors created and exported from Pix4D are 3D shapes. That means they will maintain vertical coordinates from which they were referenced to. Now in this chapter, we've learned how to create and export data files. In addition, we use Pix4D Mapper to make measurements from the ladder vectors. All vectors created maintain their 3D properties as digitized in the software. So now what I want you to do is I want you to click the Project tab and select Save Project As. Ensure that you're in your O2 project directory as it shows up here. And give the project name, that last name, and then say L6. And then click the Save button. Then you're going to allow it some time to save and navigate to your file. Then right-click that and then say Send to and compress zip. After it compresses, I want you to deliver this to your professor, and this completes your lab and your chapter for this. And we'll see you in the next one.